Hi everyone, myself Fepsin Adishman. I am working as an assistant professor in Computer Science Engineering Department. Here we are going to discuss some topics in computer organization and architecture. Here we are going to discuss about microprogram control. Microprogram control is one method of control logic design, and this is a well known and well familiar method. Normally this is use micro instructions for defining the control words or control signals. Normally this control words or control signals are stored in control memory, and normally the control memories are home memory only. The reason is that the control sequence is normally permanent. We are not altering it frequently. So we are normally writing this in a read-only memory only. So if you are taking a microprogram control, it uses micro instructions for generating the control word, and the sequence, the combination of the micro instructions we are calling as microprograms. So micro instructions means just instructions we are using for using in microprocessors. There is add, sub, like that instructions we are calling as micro instructions, and behind that this micro instruction there is a control sequence, control word is there, control signals are generated, so and so steps are there. So here we are going to discuss how this is happening. This is the architecture of a microprocessor control system. So normally the instructions are read in IR register, and IR hold the next instruction to be executed. So this is given to the microprogram sequencer. Microprogram sequencer is a component which generate the address and find the next instruction to be executed, maybe after the branch or some other operations. Then it also takes the external inputs and condition codes and finally generate the address of the next instruction to be, there is micro instruction to be executed. So that address will be moved to control address register. This is just like a PC counter register. So this, the purpose of the control address register is to store the next address of micro instruction to be executed. Then after fetching the micro instruction, it will be moved to control memory, and the control memory will provide the control memory will state the control operation of the micro instruction, that is that hold the micro instruction. Next that will be moved to the micro instruction register, and finally it is decoded and is generated control signals within the CPU and control signals for the bus. So in the case of arithmetic and logic operations, it will generate the control sequence for the ALU, and in the case of memory transfer operation, it will generate the control sequence for the system bus. So this is the overall architecture of microprogram control. So in the case of advantages, it simplifies the design of the control unit. Both it is cheaper and it is less error prone. We can clear the errors and we can test the errors easily. Control functions are implemented in software rather than the hardware, so we can have more flexibility in that. Then design process is orderly and systematic. Then it is more flexible. We can change it, we can alter it, we can change the control unit based on our requirement at any time before implementation. Then complex functions such as floating point arithmetics can be realized efficiently. And disadvantages, flexibility is also some limitations. That is, if you want to change, have a major changes in the control, you have to go for extra hardware cost. That is, if you are going for the extra hardware, it is too costlier. Then microprogram control units are normally slower comparing to the hardware control. So normally it is used in the higher smartphone devices or smart devices, and lower level devices are normally go for a hardware control unit only. Then the term coming along with this is micro instruction. That's a part of the micro program is we are calling as micro instruction. Micro instruction is single command, just like add or content of R3 with R1. This we studied in the previous topics. So behind that control instruction, it generates a control sequence. That is here for this add content of R3 with R1, we have 7 control sequence generated, and it will be illustrated like this. That is, here in this case we are sequencing all the control lines together, that is PC in, PC out, memory in, read. These are the control lines, and in the first clock cycle we will switch on the corresponding lines based on our requirement. That is, in the first timing PC out is set to 1 and MAR in is set to 1, read is set to 1, select 4, add is set to, all these are set to 1 and remaining is set to 0. And this sequence is generated as a control sequence, and this is given to various control lines. So this is about the micro instructions, and the techniques of grouping the control signals. We are having two techniques: horizontal organization and vertical organization. So horizontal organization, what we discussed previous, this is the horizontal organization. So in a single timing signal, we are keeping the control lines in a single sequence, and we are generating the control signals based on that. A vertical organization means here we are having one issue, that is PC in and PC out will not be used simultaneously, but we are using separate bit or separate lines for denoting PC in and PC out. Similarly, many inputs are not used simultaneously, so we can group that instructions. So in vertical organization, what we are doing is we are grouping that. So 4 bit, 3 bit, 3 bit, like that we are grouping. In the first 4 bit, we are grouping some signals, that is for 10, around 10 signals are grouped together, and we are giving some sequence of code for that. That is, for example, PC out is denoted as 001, MDR out is set as 0010, Z out is set as 0011, R0 out is set as 0100, like that. And the second part we are using another one group, third part we are using another one group, like that we are grouping it. So advantages in this is, comparing with the horizontal, fewer bit is required, but disadvantage is little bit slow comparing with the horizontal organization, since it requires decoding. So here we are using some coding technique, so it requires some decoding for processing. So this is a comparison given, that is a horizontal and vertical organization. So horizontal is a long format using, vertical normally it's a short, because there is a decoding is there, coding is there. Then horizontal ability to express a high degree of parallelism, but vertical there is a limitation, since we are grouping there is a limitations. Then in horizontal, little encoding or no encoding of control information is there. Vertical, considerably encoding of control information is there. Then horizontal, usually when higher operating speed is desired. Then vertical, slower operating speed missions, we can go for a vertical organization. So that's all regarding microprogram control. Thank you.